So, good morning, everyone. Welcome to lecture 3 of problem solving and computer programming course. So, in this lecture, we'll focus on two different topics. One is the programming aspect. Next is the problem solving. You are given with a particular problem. You have to find the solution to that particular problem, either by developing a particular process or a method or a approach. Once you have specified the steps, that you have to convert into a programming language. And this programming language is not limited to our C++ or C. You have to write the process in such a manner that any software programmer, if you read your process or steps or procedure, then he or she will able to write a code in a particular language. So you should not specify the space. You should not specify the steps in such a manner that it is applicable to only one language. It should be a generalized one. That we are going to discuss in today's lecture. So after the end of this lecture, you will get some of the highlights. What is a problem? How to solve that problem? And what is the next step? That is programming. That we are going to discuss. That is nothing but our implementation phase. Now, before that, let me introduce what is algorithm. Although computer science engineering people, students will get a specific subject in the higher semester about algorithms. But let us understand what is an algorithm, the basic fundamental of algorithm. So algorithm is a sequence of precise instruction that leads to a solution. Okay, I told you, you are given with a particular problem. The problem may be anything. The problem may be you want to add two numbers. Maybe you want to move a robot from one position to another position. The problem may be your whenever you are going to a shopping mall to exit from that shopping mall. So you are going to follow a set of steps, okay, in order to execute that problem, in order to solve that particular problem, right? So problem may be anything, any scenarios, wherever you want a step-by-step process, that is considered as a problem, right? And problem is defined, problem solution is defined in the form of in a process of step-by-step manner, right? You have to specify. Like if you remember in the first class, I told you, if a robot want to move from one position to another positions, you have 4 different operations. One instruction may be move towards left, another instruction move towards right, go forward, go backward. These are the 4 operations you can apply. So based upon the particular environment, you are going to execute these instructions in order to move a robot from one position to another position. Like that, whenever you want to develop a particular algorithm, the algorithm is you have to specify the instruction very clearly and very precisely. And after the end of the algorithm, means after the last step of the algorithm, it should reach to a particular solution against a particular problem, right? It may be a very simple problem or it may be a very complex problem, but you have to write the precise instruction. And if somebody will follow that precise instruction, definitely he will reach to a particular solution. That is the objective of the algorithm. An algorithm must satisfy few properties or characteristics. I have listed here 5 characteristics, but it is not limited to 5 characteristics. Many researchers or many books provided many more characteristics as well. The first characteristics is called as your finiteness. As the name suggests, finite. Finite means it should end at a particular period of time. If you want to develop an algorithm which is nothing but a sequence of instruction which leads to the solution, so you have to ensure that the algorithm must terminate after a finite number of steps. Let it be the robot problem. In the robot problem, you have defined first step, second step, third step, fourth step, fifth step. Okay. After the end of the 5th step, the robot should reach to the destination. Okay. You have specified the termination condition, right? So after the executing the sequence of steps, if your problem is solved, then we can say it is satisfying the finiteness properties of the algorithm. Okay. So while you are designing an algorithm, you have to keep in your mind, it may be step, you may require 10 steps, you may require 20 steps, you may require 100 steps, but it should end at a particular period of time or at a particular step. That is the first properties. Come to the second property, that is called as your definiteness. Definite says the algorithm's instructions should be precisely defined. Okay, it should be meaningful, it should be very clear, so that anybody want to implement that problem, okay, or solution to the problem, he or she can understand what you have written in the algorithm. That's why it is precisely defined. What kind of actions you can see here? It should be rigorously defined, okay, and there should not be any unambiguousness. It should be unambiguousness, right? Unambiguously specified. There should not be any ambiguity in your instruction. Suppose in a particular position, you have given a particular instruction to the robot or to a particular person, where there is a confusion that whether to move towards the left side or to move towards the right side. Such type of ambiguity should not be there. So in order to develop that, you need a rigorous development, as well as you have to follow unambiguousness, right? Unambiguously you have to specify the instructions so that one should not confuse at any particular period of time. So each case, whatever you are developing in the algorithm steps, you have to clearly define each and everything. That is the second property. Input to a particular algorithm, sometimes there is no input to the algorithm. That's why the minimum number of input required is 0. It is a very important question. That is, how many inputs are required for algorithm? It is 0. Because sometimes we want to show something. We don't want to depend upon what input is user is giving, right? So minimum number of input is 0. You can give any number of input, but even if you are not giving the input, that is also satisfying the properties of algorithm. Come to the output. There should be at least one output for the program. Suppose assume that I will tell you in a white paper you write hello world, right? For that you have written a program. You want to print in the computer screen, that is hello world, okay? Or in a white paper I will tell you, you write hello world, right? I have given some instructions, right? Then in the output what you will get? The message hello world through a computer program, or if you are doing it manually, you will write hello world. So in this program, if you see, it is a print statement. We are giving a print statement. Based upon the print statement, in the output it is printing hello world. So in this case, while you are executing the program, you do not require any kind of input. You have that thing you have already written in the computer program. So when you execute the program, it will not ask any input to the user. Okay, it will directly show the output is hello world. But if you go for our addition of 2 number program, I want to add 2 number. So in this case, what happens? You have to give 2 input. If it is addition number 2 number, then you have to give 2 input. Or if it is addition of 3 number, then you have to give 3 input. Then based upon your input, the output is produced. So it is depends upon the input. The output is dependent on your input, but you have to supply the input. So in this case, the input is 2 and output is 1. So in order to satisfy the properties of algorithm, you have to keep in your mind, if input is not there, then it is okay, but output should be there. So minimum number of output is 1. Fourth property is called as your effectiveness. Effectiveness says steps that are required to get the output must be feasible with available resources. Whatever steps you have specified in the algorithm, that is step, in this case, suppose in the robot case I told you, there are a 5-step process. So after going through these particular steps, you should reach to a particular solutions, and these solutions should be feasible, and whatever computer resources are there or whatever resources available for a particular problem. Resources may be anything, right? Resources is a thing that is required to complete your work. That should be available. Otherwise, that is not called as an effective algorithm. So if these properties are satisfied, these 5 properties are satisfied, or whatever you have designed or whatever you have developed, then you can claim that process is an algorithm. If one of the property is not satisfied, then that is not called as your algorithm. You have written a sequence of precise instructions, but it is not satisfying, let's say two out of these 5 properties. Then we cannot call it is a algorithm. Okay. So you have to keep in your mind while you are developing the algorithm, because algorithm is the first step of the programming process. Okay. So you have to keep that these 5 things are satisfied. Now come to program. Program is not algorithm. Program is different and algorithm is different. So in algorithm, while you have developed a particular algorithm, or once the algorithm development phase is over, what you have to do? You have to express that thing in the form of a language. The language may be specified by your end user based upon their expertise, or the language is depend on the software developer, those who are developing the software. So based upon that, we are selecting a particular language so that the same process can be understood by our computer system, right? So while you have once you develop a particular algorithm, that algorithm you have to convert to a programming language, and the language which you will convert, that depends upon your client. Suppose I have given a responsibility to you to develop a particular software. I am comfortable in X language. Then you have to define in X language. You have to write the code in X language. Or if I am not specified any language, then you will see that the programmer's skills, who is going to write the code by looking into these algorithms, they are expertise. If they are expert in C++, they can develop in C++ language, right? So you have to write in some language so that computer can understand what kind of instructions you want to execute in the computer system. So this is the difference between the algorithm and program, or you can say it is a two-step process. We are developing the algorithm, then we are converting the algorithm to a program by following the instruction of a particular programming language. These are the difference. Now, see here, suppose I will tell you to write an algorithm that determines how many times a name occur in a list of names. I have given a text file to you, right? Or a Word file to you, or a PDF file to you, in which the names are there. In each and every row, you have names. First row, the name is, let's say, Ram. Second row, the name is Syam, right? Third row, again Ram is there. Fourth row, let's say Sita is there, right? Like that, a list of names are there in the list, or the text file, or the Word file, or the PDF file. What I am asking, how many times a name occurs in that list? That means I want to know how many times Ram is repeated, how many times Syam is repeated, how many times Sita is repeated. Like that, each and every word that are present in the list, I want to know their count value. For example, if you see there are 4 words in this particular file, okay, or this list, then you can say, sir, Ram is repeated 2 times, Syam is repeated 1 time, Sita is repeated 1 time. So what is your input in this case? If you see, in order to say this is an algorithm, you have to satisfy the 5 properties. First, you have to see finiteness. Finiteness says after a couple of steps, or after a finite number of steps, it must terminate. Yes, after 5 steps, it is terminating. We'll go through this algorithm, but after 5 steps, it will terminate. First condition is satisfied. Second one is definiteness. Each and every instruction you have to precisely define and unambiguously defined, right? There should not be any ambiguity. Okay, we'll go through this one, then only we'll know that there is no ambiguity. That is the second purpose. Third is input to the algorithm is at least 0. Yes, we are giving a input that is nothing but the list that is given as a input. So it is also satisfied. Fourth is it should produce the output. Yes, it is producing the output that is nothing but the occurrence of each and every word and their count value. That is also satisfied. Fifth one is your effectiveness. So the algorithm must be effective, right, in terms of various performance measures or in terms of various attributes. Okay, you can say that is, let's say the algorithm is taking less time, then I can say it is a effectiveness. The algorithm is taking less space, then I can say it is a effective algorithm. So that also must be satisfied. So these 5 conditions you have to look what I discussed in the previous previous slides, right? So you have to see the solution must be also feasible in the effectiveness. Okay. Now come to this case. What you have to do in the step 1? In the step 1, you have to get the list of names. You have to get the list from your client. Suppose for a client, you are developing the software. Okay. For that, you are writing the algorithm. So what you have to collect? You have to collect the list of names. So list of names are there. Okay. Let's say in one row, one name is there. That is the first step. What is the second step? Get the name being checked. We are going to check the name, each and every name. We are going to be going to check each and every name. Suppose once you detect a new name, then you are adding that name to your list. Suppose first name is, let's say, Ram, and Ram is not there in your list, then you have to add Ram into your list. Or it may happen that a list is given and another list is also given in which the unique names are there. Unique name means there is no duplication. Ram, Shyam and Sita. Right? Like this name is there. That is, there is no repetition. But in this case, in this file, there may be a repetition. So we are going to check the things, right? Either you are preparing a new list to check, or once you are identifying a new name, you are putting in another list. The name you have to check. Third step is you have to set the counter. I will take a counter with respect to a unique name, and once the name is identified in this particular list, I will increase the counter. So initially the counter value is 0 for each and every word. Right? That is the third step. What is the fourth step? Do the following for each name on the list. First, one word I will take. What I will do? Compare the name on the list to the name being checked. For example, the name being checked is Ram. Right? I will check the first word is Ram or not. Yes, the first word is Ram. The counter value is 0. Now I am increasing the count value to 1. Right? Suppose the second one is Shyam. So I am checking whether it is Ram or not. It is not Ram. So I am not increasing the counter. If it is not satisfied, then I am going for Shyam. Okay. I am checking whether the second word is Shyam or not. Yes, the second word is Shyam. So I am going to increase the counter of Shyam to 1. So here one name may be specified or a list of unique name is specified. By looking into that, you have to increase the counter. So we are comparing the name on the list to the name being checked. Okay. The name in the list, whatever given by your client, and the name being checked. These two things you have to do. So if names are same, like here you have seen the first word is Ram, and we are also name being checked is Ram, then we are increasing the counter. Okay. Then add 1 to the counter. Counter value is increased to 1. Initially it is 0, now it is 1. Again it will detect a Ram, then it is increased to 2, 3. Like this it will go. What you will do after a couple of steps or after reaching to the end of this particular list, a list is having finite number of input. So once I'll read each and every input, I'll reach to the end of that particular list. So I'll announce the answer is the number indicated by the counter. Suppose you have given a single word, I will say Ram is repeated twice. Okay, based upon the repetition of the word Ram. If you have given Syam, then I will say Syam is repeated one time. If Syam is there in one time in this particular list. Okay, so if you see these 5 steps are following all the properties of an algorithm. That's why we call this one as an algorithm. So here our problem, what is our problem? The problem is to find how many times a name occurs in a list of names. Okay, like that for each and every problem you have to define the sequence of steps. That is nothing but solution. For this particular problem we have, this is the solution, right? Now come to the program design. So programming is a creative process. It is not a static process you have developed and that's all. In various aspects, if you see, it is completely a creative process. So sometimes what happens while you are designing the programming, you may have missed some case. Okay, suppose you know that, suppose in the case of robot, if a robot is present in one location, there is 4 different operations you can execute, right? You can move left, you can move right, you can go forward, you can go backward. So sometimes while we are writing the program, we have to include the 4 operations, but due to some problem or due to some lack of knowledge or due to some misunderstanding, you have missed one condition. That may happen. That may happen, right? So these things will come automatically based on your experience. So no need to worry in the beginning phase. Beginning phase you will identify errors, right? More errors will come, but slowly you will learn this process. So it is a completely creative process. So simply you can see for any product design, we are generally going for prototype. If prototype is satisfied, then we are going for a big model. If prototype is not satisfied, okay, then we will improvise another thing to develop a new prototype. So this is a continuous process. And there is no complete set of rules for creating a program. Somebody should not give 100 instructions or 200 or 1000 instructions. If you follow the 1000 instructions, then you can create a good program. That is not like that. It is based upon your learning process, based upon your creativity. Okay. So you can see, you can sometimes you may think that why not we apply this instruction here, this instruction there. So you have to try. Once you try, you will know the output, then only you will gain the experience. So don't think that if you learn 100 programs or if you solve 100 problems, you can do any program. No, that is completely a creative process. Sometimes a new problem will come for which you may not write a particular code. So that will come based upon your experience. So the program design process is divided into 2 parts. As I mentioned, first one is called as problem solving. Second one is called as our implementation phase, that we are writing the code. In order to solve the first phase, that is the problem solving phase, what we are writing? We are writing an algorithm that solves the problem. Okay, and what is an algorithm? Algorithm is a step-by-step process. That is the first phase. The second phase is our implementation phase. In implementation phase, what happened? The input you have to give to implementation phase is an algorithm, and that algorithm should not be meant for a single programming language. You should not specify, like in the previous slide, I told you an algorithm. The steps does not mean that you have to follow C++ or C or Python or XYZ language. Algorithm should be free from all the language. That is nothing but you are giving instructions. It is up to the programmer to follow which language. That's why we are giving input algorithm to the implementation phase. Right? So once you are giving input to implementation phase, that is algorithm need to be translated to a program through a programming language. So I am comfortable in C++, so I will write a C++ code by looking into your algorithm. Okay, and I am able to do it if it is precisely defined, unambiguously defined, and it should be effective. It should be feasible. It should be with my available resources. I can write that code. Then only I can write the code. That thing you have to keep in your mind while you are designing a particular algorithm. Right? So these are the two phases which we are following. First is problem solving phase. Once it is completed, algorithm is ready. Algorithm is given input to the implementation phase. Implementation phase is going to provide you the programming language. Through the programming language, it will give a particular program. Now, in the first step, let us go to the details about the first phase, that is problem solving phase. Be certain the task is completely specified. You have to assume that all possible things you have clearly specified in the algorithm. Especially, you have to focus for a particular problem, what is your input and what information is in the output, because each and every problem statement is different. By looking into the problem statement, you have to see these are the parameters we have to give as an output or give as an answer. Third one, how is the output organized? That is nothing but a process. How is the output is organized? How you will convert once you receive the input process? What you are going to do? That you have to specify. So these three things you have to keep in your mind. Next is develop the algorithm before implementations. Before going to the implementation phase, you have to carefully, rigorously develop the algorithm. And experience shows this saves time in getting your program to run. If you have clearly defined the instructions in the algorithm, then it is very difficult for a programmer to write the code which saves the time. Okay? So, how you are going to check whether your algorithm is performing better or not, or your algorithm is well defined? So, you have to test your algorithm. You have to test with different things, right? Somebody will say that if a row, in a particular list, a row is blank. I told you, each and every word you have to write in a one sentence, one row. In a text file, you will write the name in the list. In each and every row, you have one name. Let's say in one row there is no name is there. Then what to do? Such things you have to analyze. Right? Or you know that the name is nothing but, in Indian context especially, the name is nothing but alphabet. There is no special characters. Or there is no fancy alphabets. But you can see other country people, they are using fancy alphabets. If such a thing will happen, then whether that thing is specified in your algorithm or not. So you have to check your algorithm's correctness. If you will look into these things, then only your implementation phase is more easier and saves your time. Come to the second page. What you are doing in implementation phase, you are translating the instructions given in the algorithm into a programming language. That is nothing but your program. So based upon your experience, don't think that first attempt you will do the things. It may require to write a program in, you can write a big program in 1 month or 2 months of time. Suppose you are writing a code for your BTech project, then it will take time. Don't think that everything you can complete in one single day. It will take time. Correcting the algorithm, correcting the code also takes time. Thinking about different logic. So suppose I am thinking a particular logic, but I have missed some of the additional things. Then also I am getting error. Such type of things you will learn based upon your experience. Okay. Then once the programming is ready, you have to compile your code, which we call as your source code or program. Okay. Let your program is ready in some programming language. So the next step is you have to compile the source code. What do you mean by compile? Compile means checking that whatever things you have written in some programming language, whether it is correct or not. That is nothing but we are locating the errors. We are going to locate the error in the system, error in the program. Right? Sometimes what happens while you are writing something you have mixed. Right? some comma you have missed, or some full stop is missed, or somewhere while you are writing the letter also, sometimes you have missed many things, right? Sometimes there is a grammatical error, sometimes there is a spelling mistake. Is there in a particular letter while you are writing? Similarly, while you are writing the program, sometimes you are missing semicolon, sometimes you are missing equal to sign, something like that. You want to write less than equal to, but you have missed equal to. So such errors will be identified by the compiler. After that, after compilation is over, what is the next step? The next step is you have to run the program. It is again a two-step process, you can say. Initially, it is a two-step process, that is problem solving and implementation phase. Implementation phase is also two-step process. One is your compilation. Once you have done successful compilation, there is no error, then you can go for running the program, right? Run the program on sample data. You have to give some input, okay, like the list or the number. Then you can check whether your program behaves correctly or not based upon your algorithm. We are going to check the correctness of our result, right? So a successful compilation does not mean that you will get the result. Note that this is a very important point. If successfully your program is compiled without any error, without any warning, that nowhere related that your program will be successfully run in the computer system, or the program will give you correct output, right? A program will run, but you will not get your expected output in some case. Then again you have to modify your code, and this process you have to continue until unless you will say that yes, all the results are correct. So we are verifying the correctness of the results. Okay. So results may require modification of the algorithm and program. That's why I told you, you are developing a prototype. The prototype may be revised, right? You have to revise the prototype. Couple of steps you are doing. After that, you are getting the correct prototype. Okay, or you are designing an algorithm, but it is providing error. You are again revising that algorithm. Again, you are getting error. You go on revising the algorithm and program unless whatever you are expecting, the same thing you are getting as an output. That you have to do. For example, see here, I want to design an algorithm for factorial of a number. What is the input? To find the factorial of a number, you have to give a particular number. That is, I have written as n. N may be anything. You can say n may be 1, n may be a big number like 1000. So n may be 0 also, right? I can give any number, any input from 0 to 1000. So what is your input? Input is your given number, and suppose those who do not know what is factorial, I am telling you, 3 factorial is nothing but what? 3 into 2 into 1. Right? That is nothing but you have to give your input as 3. Then you will calculate the factorial of a number. That is nothing but, if this is n, this is nothing but n minus n. This is nothing but n minus 1, n minus 2. Like that, you have to go up to what? Up to you reach 1. Like 4 factorial case, you can say it is 4 into 3 into 2 into 1. That is nothing but your n is equal to your 4. This is your nth term. This is n minus 1, n minus 2, n minus 3. So as you have reached 1, you have to stop. So this is the formula you have to do. Okay. So this is a problem. Finding the factorial of a number is the input. Finding the factorial of a number is the problem. Your input is a given number n. Your output is your factorial. That is nothing but in this case you are getting 6. In this case you are getting 24. That is your output. But the question arises here, computer can perform only single multiplication at a time. In computer, I told you about ALU, right? Arithmetic logic unit. It is doing addition operation, multiplication, subtraction, division operations. Computer cannot do multiple tasks at the same time. If it is doing multiple tasks, it is one by one. It is one by one. If you are writing parallel programming, then it is possible to write two instructions can be executed in two different core of the computer program, but that is different thing. We are going for a sequential programming. That's why one instruction you can execute at the same time, or one multiplication you can do at the same time. So how to solve this problem using a computer? That is the question. Come here. So I want to write a algorithm for factorial of a number. Let the number is n. So I am expecting n factorial. So see, I have to define the 5 characteristics to check that whether the algorithm is correct or not. And the very important characteristics is your input and output. So what is your input? Your input is the variable n. Your output is nothing but the factorial of that variable. And apart from that, what we are doing is computer cannot perform computer cannot perform multiple multiplication at the same time. That's why we need one more variable that I have taken as result. You can take any variable. You can say your name is also a variable. That is okay. Or somebody will write still, sir, I will take res. It is also okay. Somebody will say I will take r. That is also okay. I will come to that later pages. Okay. So consider one more variable, that is result. What result is doing to do? Result is keeping the multiplication of only two numbers. It is not possible to multiply all the numbers at the same time. So result is keeping only multiplication of two numbers. Suppose n is equal to 5. So initially we initialize the result value as 1. Like previous case, the list case, I told you the counter is generally initialized to 0 because we have not seen the name in the list. Once we will identify a name in the list, then we will increase the counter to 1. But as there is a multiplication means if you write initial value is 0, then everything will be 0. You know that 0 multiplied by anything is 0. But when you go for multiplication, you should initialize the variable by 1. Like here I mentioned result is equal to 1. But whenever you are going for addition, you add any number with 0, you are getting that number. So in that case, we have taken the value as 0. So don't be confused. Addition case you are taking 0, multiplication you are taking 1. Right? Now, suppose the value is given here as 5, n is equal to 5. And initially the result is equal to 1. Right? So what I have to do? I have given an instruction that is result is equal to result into n. So simply an instruction I have written. Whatever the result value is there, okay, here it is 1. It should be multiplied by the n and stored in that result. Right? Result is a variable we have taken. Okay, and generally the instruction is we are reading from right to left. This is the right side, we are moving towards the left side. So we are evaluating result into n, then we are updating the result as whatever the outcome of result and m, their multiplication. So in this case, you know the result is 1, so I am keeping 1 here. N value is 5, so I am writing 5. So 1 into 5, your result is 5. Then once you have updated the value of result, then there is another instruction, you have to decrease the value of n by 1. So initially n value is 5, so I am writing here so that it is more clear. Initially n is equal to 5. In result case, I am writing r, or let me write result so that you will not confuse. Result is equal to 1. First instruction, what I am doing? Result is equal to result into n. So 5 into 1, 5, and I am updating in the result. So 1 is replaced by 5. Now what I have to do in the second step? Second step, I have to decrease the value of n. If you decrease the value of n, the value is now 4. Now what you will do? You will again execute the instruction 1. Instruction 1 is result is equal to result into n. That means 5 into 4 is 20, and that should be updated in the result. So you can see here 5, 4 into 20. Then what is our second step? Decrease the value of n by 1. So this value is now 3. Then what I have to do? I will again execute instruction 1. Instruction 1 says result is equal to result into n. So 20 into 3 is your 60, and that should be updated in the result. And the second instruction, you have to reduce the value of n by 1. Then what you will do? Again, perform the first instruction, result is equal to result into n. So 60 into 2, you are getting 120. So that you are keeping in the result. And decrease the n value by 1. So you are getting 1. So when n is equal to 1 is identified, you have to stop the process. And whatever value is there in the result, like here it is 120, that you have to return to the user. This process we are following. Right? Until unless you reach the n value is equal to 1, you have to perform these two instructions. Result is equal to result into n, reduce the n value by 1. And if n value is 1, then you have to stop. Right? This is the process we are following for factorial of n number. This is a rough calculation. Now, we have to write the algorithm for n factorial. What you did in the previous slide, first you read the value of n. You do not know what is the value of n, right? User may input 5, user may input 1, user may input 0 as well. You know that 0 factorial is 1. Remember, this is a very important point. 0 factorial is 1, not 0 factorial is 0. Right? 0 factorial is 1. You can also keep a condition. If a user is entering 0, then 0 factorial is 1. If a user is entering a negative number, then you will say that no, the input is not correct or wrong input. So initially you have to read the value of n, then set the value of result to 1. Initially, as it is a multiplication, we are keeping the result as 1. Initially the result value is 1. Third step, we are writing until unless the n value is greater than 1, you have to continue two process. One is result is equal to result into n, that is the new value of result to the old value of result. Right? You are calculating old value of result multiplied by n, and you are declaring that value as a new value of the result. In the next step, you are decreasing the value of n by 1. That is nothing but set the new value of n to old value of n minus 1. So this process you are iterating until unless you are reaching to 1. Finally, once this process is over, or once this n is greater than 1 is not satisfied, because initially n value is 5. So here the value is decreased to 4. Now the value is 4 is greater than 1. Now the value is decreased to 3. Now 4 is now the value is 3. 3 is greater than 1. So you are entering to this inside this instruction. You are reducing it to 2. Then 2 is greater than 1. You are coming here. It is 1. Now it is 1. So 1 is not greater than 1. So you will not enter to these two steps. Right? So once you have failed in this particular step, failed to enter this particular step, then you have to do print the result, the value of the result you have to print, that you have to return to the user. Right? This process you have to follow. Don't forget about what is written here. This is just a process, right? I will tell you formally that what is the meaning of this one. So you are executing two instructions inside this one, right? That is, you are updating the value of result, that is result is equal to result into n. Second is n is equal to n minus 1. And finally you are returning the result. Now, I am giving you two exercises that you have to complete. First one is, you have to write an algorithm to compute the quotient and remainder when a given integer x is divided by another given integer y. I want to perform x by y, right? Where x value and y value is greater than equal to 0. Okay? So you have to find the quotient as well as the remainder. For that you have to write the first algorithm. The second one is to assume that only addition and subtractions are available as primitive arithmetic operation. Yes. So in this case you assume that, so this is the hint to this particular question, that you have to assume that only addition and subtractions are available. other operations are not available. Right? That is, multiplication and division operations are not available. By keeping in your mind, you have to develop the algorithm. Right? So this is the exercise for you. Now come to the program design process. So I already told you there are two-step process. One is problem solving, another is implementation phase. Right? Implementation phase again is, I told you there are two different steps are there. One is your compilation, another is your running the program. So in the problem solving phase, what you are doing? You are starting with a particular problem. You are defining that problem. You are suggesting a particular algorithm by following a algorithm paradigm. Then you are testing whether that algorithm is working or not. That is nothing but verifying the correctness of the algorithm. So if the algorithm is not correct, then what you are doing? You may return to the algorithm design to modify the algorithm, or the problem definition, whatever you are defined, that is not clear. That's why you back to the problem definition, you are revising your problem definition, then going to algorithm design, then desktop testing. But once the algorithm is successfully designed, you are moving from the problem solving phase to your implementation phase. In implementation phase, you are translating your algorithm to a particular programming language. So in this case, the programming language is C++. That's why it is written as translating to C++. Then you are performing the compilation and running. That is nothing but testing the program. If there is no work, no problem, you are getting your output as expected, then you can say the program is working. If not, then you have to modify the code unless your output, whatever you are getting, that should be meet your expectation. So this is the process we are following in the program design. So C++ is also called as our object-oriented programming language, OOP. Java is also called as your object-oriented programming language. Or in the rest of the discussion, we will use OOP, that indicates object-oriented programming. So it is used for many modern programs. Many people, whether it is academic community or business community, people are using this language, C++, a very popular language. Java also is a very popular language, but the concept of OOP starts from your C++. So here, if you see, the program is viewed as an interacting object. In C++, everything is treated in the form of object. You have written a program, right? I will create object for particular program. Let's say my object is O1 and O2. Okay. Now O1 holds this program, O2 also holds this program. So it is saying here, each object contains the algorithms to describe its behavior. The behavior of O1, O2 is different. O1 may be meant for addition of two numbers. O2 meant for addition of two real number. One is meant for, let's say, integer, that is 2 or 3. Another object is meant for 2.2 and 3.2. That is real number, or double number, or floating point number. We will come to it in a later stage. That is the meaning of these things. So O1 is only taking the number if there is fractional part is not there. But O2 is meant for both things. You have to specify a fractional part. That's why each object contains algorithm to describe its behavior. And they are acting differently. So the program design phase involves designing objects and their algorithm. You have to design the object and their algorithm. Each object is holding an algorithm, containing an algorithm. So this design phase is going to do that, right? Now OOP has a set of characteristics. The first characteristics is called as encapsulation. So encapsulation is nothing but you are hiding the internal details of the things. Suppose somebody is not aware of a particular thing, then what you will tell? Suppose I am not familiar with the terms of a particular digit. So you will say that that person is having that digit without going into the technical terms. So similarly, here in C++ or object-oriented programming, the properties encapsulation provide information hiding. And each and every object in the program has their own data algorithm. Like I told you in the previous case, somebody is taking 2 and 3, some object is taking 2 and 3, another object is taking 2.2 and 3.2. This is one of the characteristics. The second characteristics of P is called inheritance. Like we know in our real life, we are inheriting the features of our father and mother, that is our parents. Some properties is we are inheriting from our parents. So C++ or OOP is providing a feature that if you have written some code somewhere, that code you can invoke and use. That is called as your reusability. Somebody has defined something in somewhere, I am inheriting that code to my work so that the repetition should be avoided. So that is nothing but you are writing reusable code. Object can inherit the characteristics of other object. One object is doing a particular work. I want to do I have created another object. The object also need to do some work that is specified by other object. So I can take that characteristics from other object and I can do further works. That is possible by the help of this inheritance property that we are getting in the code from other objects. Third is called as polymorphism. Polymorphism says the single name can be used for multiple meaning. Like if I tell need, somebody may say that need is same as require. Okay? Need may require what he is wanting. So a single name may have multiple meaning. Like you have defined a single function and that function is meant for multiple purpose. That's why polymorphism provides a feature that you have to define one thing and that particular thing can do multiple works at the same time based upon the input. If you are giving the input as 2 and 3, it behaves differently. If the input is 2.2 to 3.2, it behaves differently. Like that, right? Now, if you go for the software life cycle, whenever you are developing software, you are going for a set of steps. The first step, you have to analyze it. While you are developing a particular software, you have to go to your client. Why you have to go to your client? You have to collect the requirement. The client will specify what is the problem, what are the problems, what solution they want, input, output, everything will be mentioned by that client. So first step is you have to analysis and specification of the task. By interacting with your client, you have to identify the problem, that is called as your problem definition, which is very important. If the problem is not clear, then the software development life cycle will fail. So once the problem is clearly defined, the second phase is you have to design the software. In this case, you are using your object and algorithm design. You are defining the process in which you want to solve that particular problem. Once the design phase is over, you are giving that algorithm to the implementation people or the coding people. They are writing the code based upon your algorithm. And once the coding phase is over, the next phase is you have to test the code. You have to test the code whether the code is correctly working or not by giving a different set of input. And the next step, you are doing the maintenance. So one software you have defined today that is working fine, but tomorrow the requirement may be different. So the maintenance is required. Like whenever we are purchasing a product, let it be fan or refrigerator or AC. So maintenance period is there for 2 years, 3 years, warranty or guarantee period is there. Okay, and this process is repeated. This is not a single one-side approach. You have to go for 1, 2, 3, 4, 5 like that. Sometimes you have to go from the step 3 to step 2 to correct the things and coming back to again step 3. And last phase is obsolescence. right? So these are the steps you have to follow in the software life cycle. So this is the questions you have to take from this particular lecture that indicates. First question is describe the first step to take when creating a program, that you have to write. Second one is list the two main phases of the program design process. Third one is explain the importance of problem solving phase. Is it required or not, and how it is different from your implementation phase. Fourth one is the list the steps in the software life cycle. So after the end of this lecture, I hope these questions you can successfully answer.